separate records of material library?
Yes. Yep. So when you open Granta, this is going to be the first page that you're going to see. You can see Granta Selector, which version you guys are using and pulling the data from. And then you can still see the details of the what materials are going to be included. So if you want to just focus on metals and polymers and you don't care about composite, let's say, go ahead and uncheck composite here and move forward. So I'm just going to keep everything and I say continue. And I will wait. Perfect. So we have material 1 and 2. Basically, if you select metal plus and polymer plus, it will show up in your material universe, but it essentially doesn't matter really which one you select. All the data will be available. Okay, and I selected the metal. So this is the very first page of the product itself. So on the left, you see material universe. So we have data for ceramics and glasses, fibers and particles. And then hybrid material for composite, foam, honeycomb, natural materials. So if you have, let's say, a material for your composite, for whatever reason you're designing composite here, and then you want to say, oh, I want a fiberglass. This is my stitches direction. So like 45 degrees. This is like, this is my carbon epoxy properties that I'm looking for. So you can find all that information here in a composite. We provide actually a bunch of different foams material. So if you are developing a foam in-house, you can bring it to Granta and then compare with other foams where your foam is. Liquid and gases. So you guys are trying to develop a 3D FSI for your valve. So that valve could work in different conditions. If it is pumping water salt, if it is water and scraps, if it has a stone in it, if it's an oil, whatever it is, you can select some of that material potentially here. Magnetic materials, metals and alloys, polymers, plastics, and elastomers. So this is generally what we have here. What I'm going to do is I'm going to click on metals and alloys, ferrous, tool steels, S series, and then I check out S7 here. So I would say over 90% of the data that you're going to see here is standard for the entire materials that we have here, except some of the testing data. So sometimes for mechanical properties, I'll show you in a little bit that we provide the range, but we don't necessarily have the stress strain curve and the little detailed data for that. So we usually start with the condition of the material, UNS number, what's the US name, if there is any other name for that, like if there is an EU name, if there is like a Chinese name for that, we provide all of that here as well. So it helps. What's the essentially the composition of the material? Down here we can see how much carbon does it has, how much chromium, iron, and you can see sulfur, silicon, everything is the percentage of that. And again, as you can see, it's the range. We don't provide you exactly because each vendor can do it differently. So Tata Technologies or Tata Steel may do it different with your Chinese vendor that you have. But we have reviewed what they're offering based on the handbook, and we give you that range here. So, and then there are typical uses for each material. So it's a cutting tool, single point top, milling cutters, drills. So you can see, oh, okay, so I see some applications for this specific material. And then we have compositional summary. I'm going to scroll down a little bit, and then we get to price. So we offer 2 price here, and again, it's a range. USD per pound. You can also change the unit for this specific one. So you can come to tools, settings, and then units. You can change your unit here as well. So if you want different currency for that specific time that this data is released, you can check what was the currency conversion, and then select for different currencies and see what's going on, and also checking if you want to check it for SI units as well. So then we go to physical properties, density, and then mechanical properties. So as I said, we have a range. All the details of the mechanical properties are here, including hardness. That you asked for hardness, Vickers, Rockwell. That information is here. I'm going to scroll down, and then sometimes specifically for this properties, as you can see here, we provide a graph. We have a fatigue strength versus number of cycle. And then we have this little graph on the top right corner of that graph, which if you click on it, it will open another tab on top. And then you can see that what exactly was there. And so the data for this one, let me go back. I know that it's somewhere here. Have the stress ratio. I'll show it for a different material. This one is a little different. I'll show it for like, I don't know, like 4140 or something. But yeah, usually when we have a graph, 99.9%, we also provide the detailed data for that as well. And then impact and fracture properties.
Because it was based on inclusion.
Oh, okay. Okay. Yeah, I didn't check for this one. There are a couple of materials that I wanted to review with you guys, and I checked all of them. This is a specific one I haven't checked. So if it's based on equation, obviously we don't have that. Impacts and fracture properties, thermal properties. So sometimes the what your valve is designed for, or what your pump is designed for, it needs to work in a very hot environment or a very cold environment. So the products that you guys design, sometimes it is working in all the way north of Quebec. Sometimes it may work in Africa somewhere super hot. So you can see for that working condition and add thermal properties to your design and for your simulation and see how your product is behaving. And then we have electrical properties. I'm just going to skip some of these. As you can see, we even have optical. I have zero knowledge on the optical and magnetic and electrical, so I'm not going to pretend that I know any of them. But you can see healthcare and food. So if this material comes to a food contact, is it going to be safe or not? And then guidance for MRI, restrictions. And another thing that you guys may care about is processing properties. So this material that I'm selecting, is this going to be good for casting? This is unsuitable. Is this good for metal cold forming? Unsuitable. Hot forming, limited use. So you can see each in a specific application. If you are planning to manufacture your product with this specific material, what would be the processing properties? Is it suitable or it's not? This is something that I think might be interesting for you guys. Yeah, so basically you see that it says unsuitable. What does unsuitable mean? And then you can open it here and then say unsuitable, the material is not used for casting. And then you can read some of the details of what exactly do we mean when we say excellent, acceptable, limited use, or unsuitable, and the details of that. Yeah, absolutely. So we have additive for additive manufacturing, we do. For injection molding, I do not know. Yeah. And then durability, as we talked about. So you can see for different contact with different product, water, salt, weak acid, strong acid. What is that? And then obviously you can click on like weak acid and then go read a little bit about it. What do we mean by weak acid? Because it could be relative. And then I know based on the initiatives, the carbon footprint sometimes could be important. So we provide processing energy, CO2 footprint, and water. So you can see for different processes, what's the CO2 footprint, and basically we also provide a range. So if you have, like, you can come up with something green, something like that. I don't know. I'm making up some terms here. And then you can set your standard and say, this product is clean. It has our own certification based on what we selected for our material and the processes that we're putting together. This is the carbon footprint for this material. So we certify that. And then recycling end of life. And then I'm just going to skip this. There's so much information for each material is here. I'm sure you guys don't want to hear me going through all the single detail of that. Yes.
Global equivalence up top. For the GB equivalent it had there, it showed that it was roughly comparable. I know, like in this instance, the chemical and mechanical properties are a little bit different.
Mm-hmm.
Are those other equivalents? Do we have data sheets for those, or just that it's roughly equivalent to this? Like, can you actually pull up and compare it specifically to its GB equivalent?
Yes. If you want to specifically compare a data of a material with another data, I'll show you in 1 second how you can do that.
I guess the broader question is like for steels here, is this all the data here? Is it all going to be AISI or have GBs in there?
Yep. So when you scroll down, you see a couple of other things here. So one of the things that you guys may care about is producers. So you can click on it and see a list of producers that we checked our material with them, and we know they are providing it. Now, within that range, where do they provide elongation? Where do they provide stiffness? Where do they provide, modules of elasticity? That's a different story. That's something that the customer needs to call them and ask them for a spec sheet. And then another thing that we have is references. So you can go to references here, click on it, and then see for what we checked this material data with. And one couple of more information you can find in jump curve data. You can click on it and see some of the curves here. So we have two different parts here that you may care. Material universe, jump data. Material universe is what we saw. Jump data is all the curves. So let's say density versus temperature. If you click on it, come here to view, click on data, you can see all that testing data here. This is not like an extrapolate of some curve somewhere. This is the testing data that you can come here and find it. You can literally just copy paste this or bring it to Excel, or if you want to manipulate it somehow, you can definitely do that. So now I'm going to
Like that data, could you then use it? Or?
You can bring it, you can take it out of this, bring it to your SolidWorks, bring it to your Ansys, and then change it there. Yes. Yep. Because as I said, here we provide a range, as you can see here. And then when you export it, it gives you the mean value. Sometimes you're like, I want to be conservative for my modules of elasticity. I want to choose the mean value. And then you can go ahead and change it in your Ansys. Yep. Or SolidWorks. So I want to compare this material with other materials. So I'm going to right click on it and say, set as reference. I want to have this material as a reference, and I want to compare with tempered at 205 Celsius. So I can right click on it and say add to comparison table. And then I can scroll down, and this is highlighted, as you can see. So on the right side, I have the tempered at 205 Celsius, and on the left side, I have just annealed of S7, and then you can see it's been highlighted, the differences. So this is one way that you can compare your two different materials. So if you are caring about hardness, then you can come here and say, oh, I see that the Rockwell hardness is changed, and when it is tempered at 205, it is more than 100% difference here. So you can say, okay, this is a harder material. I'm going to go with this. This is the criteria I care about. You can check that definitely here. So if you scroll down, you can see that all those comparisons are highlighted here. So if you in-house developed a steel developed a foam. And when you bring your material here, then you can set yours as a reference and then add multiple others that are close to what you have to compare them with each other. And then Granta will highlight that for you, what's the difference in terms of value for each and individual detail. So this is one way to compare them. Another way to compare them is if I plot a chart. So I click on the chart and I say, I want to look for material for tool steels, right? I want to compare my S7, where exactly it is standing. And then I'm going to define some index. For my X index, I care about price. And then for my Y index, I care about physical properties. You can come select physical properties density, or you can come or select mechanical properties and select Young modulus here, and then hit OK. And then here you will have a graph. Now, where is your reference? You can come here, click on it, and then here's your reference. So for the X graph, I have price USD per pound. So when I go more towards the right, the materials are getting more expensive. And then Young modulus on my y-axis, it's PSI. So you can have this material, this is your reference, and you can compare it. So sometimes you're like, okay, I want to select within the neighborhood of my own material. I don't care about what's up there because they are very expensive. One thing you can do is you can come here, select some of those here, and then the rest will grade out. And as you can see, it's kind of like an oval. And the reason for that is, again, it's the range. So you're comparing within the range. This is actually more accurate instead of having dots on a single point in a chart. Because you can say that, okay, this has a mean value and a max value, and I'm comparing mean and max of a material with mean and max of another. So this can help you to make a smarter decision here. As soon as you select that, then on the left side, you can see that, oh, the materials, we went from 82 to 47. Okay, that's cool. Now, I want to add more more criteria for my material. So I'm going to select limit. And then you see that there are a bunch of limits that you can add here. So I can go to healthcare and food. I'm going to say, oh, I want it to be yes. I want the materials that I'm selecting to be yes for this specific change. Now I can hit apply. Now we have 47. If we hit apply, now we have 37. So if we go back to our chart, which is here, now, as you can see, my boxes still exist here, but some of the materials behind my reference is grayed out. Why? Because they're not passing the food healthcare contact for my food. You can add more limits to it. You can come here and say, I care about durability. I want it to be acceptable for contact with water and salt and excellent, right? You can do that and click on apply, and then you see 0. Oh, so none of those materials are supporting water salt contact? No, they're not. So you can come back here and then apply, and then 37 material will be back. And as soon as you hit apply, then you can come back to your chart, which is a stage 1, and then see what's out there. Now, this is a general idea of how you can select it. Do you have any questions so far? I'm going to grab a bottle of water.
How do you click on a specific material?
What's that? Oh, yeah. So you can just come here, select this material. The name will show up here. You can double click on it. It will go to that page. You can read it and add it to comparison. Compare your reference with others. Yep. Or let me see if I can right click and say add to comparison. Oh yeah. Yep, we can do that. Yep. So you can select it from the list here, or you can select it from the graph. Usually it's from the graph because you can have a comparison. You're like, oh, it's more expensive here, but from the chart you can't really tell if it's expensive or not. So this is individual comparison, like 1 point Young modulus versus price. Now, another thing that I can do is I can define a performance index finder. So for my x-axis, I'm going to have a still price per unit volume. For my y-axis, I'm going to define as a performance index finder. Sometimes the material is expensive, more expensive than what you have in mind. But when you compare it with price per unit volume or modulus of elasticity per unit volume or per unit mass, then the prices can change. And then it can help you to optimize it. So I'm going to select for a tie intention. Obviously, you can select a different loading criteria if you have, and then you can select tension, and then you can say, I care about stiffness per unit volume, right? Or you can change this. You can have strength, you can have vibration, or you can have per unit mass. So I'm just going to keep it as it is, and I'm going to hit OK. And you see this chart, stage 4 and stage 1, they have a different representation. Because now I am optimizing my selection for stiffness per unit volume. So on the left, unit per volume of a stiffness, and on the x-axis, I have the price. Yes, this material is more expensive, but volume per unit of a stiffness is less. So it's not just about a single point comparison between two material. Sometimes it's all about what happens in a bigger scale. How can I smartly select my material? So that's why selecting it for your application could be important and optimizing that selection. So this is what Granta Selector brings to the table. It's not just, oh, we tell you what's the range of modulus of elasticity. That's good, yes, but how can I actually manipulate my data to make a smart decision? This is what it's about.
So what you're saying there is that you could use one of those materials on the right that it costs more, but you'll use less of it.
Yes, correct. Absolutely. All right, so now let's say, where is my reference? Here is my reference. Where is my reference? Here is my reference. So I have my reference. I'm going to select, for whatever reason, this specific material here. I'm going to double click on it. I've selected, it's good. And then, or one of the materials in a chart, I can come to stage 1 and then 7650. I'm going to select this one and I'm going to say highlight. Okay, it's right here. Where is my reference? They're pretty close, but that's fine. I'm going to select this. Now I'm going to export it to Ansys Workbench.